Welcome back. Now I am going to introduce a very interesting concept. The concept is that of second law efficiency. Now you know what is efficiency, right? Efficiency is output upon input. Now when it comes to any heat engine, the output is in the form of work, input is in the form of heat. So work output upon heat input is efficiency. So if you go to a steam power plant, efficiency of a steam power plant will be the output energy which you get at the turbine upon the heat supply which you get at the furnace. How much heat is supplied? That is your efficiency. Okay. But now that efficiency term comes from the application of first law of thermodynamics. Okay, first law. Because you are essentially saying that energy cannot be created nor be destroyed. It's only converted from one form to another form. So what is how much of the heat is converted into work? That is what is given to you by efficiency. Work output upon heat input. What fraction of heat is converted into work? Right? That's what it is given. Efficiency of any heat engine is work output upon heat input. Now we are introducing a interesting concept, and it's called as second law efficiency. Now we will compare the actual efficiency of any heat engine to that of an ideal engine, which is also working between the same temperature limits. Okay, that means Carnot engine. So what we do is we will consider, for example, let's say steam power plant. In a steam power plant, we say that we will imagine, let's say that heat is supplied in the boiler. That means from the furnace, heat is supplied to the boiler. We'll consider what is the temperature at which average temperature at which heat is supplied. Okay, average temperature at which heat is, when the fluid which is receiving the heat, right? And here are the flue gases which are giving the heat. So we'll consider the temperature of the flue gases, average temperature of the flue gases. That will be your source temperature. And heat is given out at the condenser. So when the heat is rejected, that temperature at the condenser we will consider as sink temperature. And then we'll find out the efficiency T1 minus T2 by T1. So we are considering a Carnot engine running between the same temperature limits, and we find out efficiency. Our actual efficiency, as I told you, work upon heat. Okay. Now, it's obvious to you, must be obvious to you, that the efficiency of Carnot engine will be highest. So efficiency, so what we will do, we'll compare the actual efficiency with that of the Carnot engine efficiency. Okay, and we write that ratio. So second law, the second law efficiency is the actual work output upon the work output if you could run a Carnot engine. Okay, you cannot run a Carnot engine. That's the ideal thing. But actual work upon Carnot work, one can say. Okay, so that's basically efficiency in terms of efficiency. So that is what is second law efficiency, right? That is called as second law. Let me tell you this. Let me explain you here. Now this, you have just seen this expression. Please note that this expression, while we arrived at this expression, we have used this running of Carnot engine, and we have added this work to this work, and we have arrived at this. But when you use the steady flow energy equation, you don't do such things. There you are not interested in finding out maximum work. There you are interested in just finding out work, the actual work. So how will you find out actual work there? All that you do is you apply steady flow energy equation. You say that energy at section 1, you consider all the heat and work interaction, right? And just write the energy balance equation. So your equation there, if you remember, is U1 plus P1 V1 plus V1 square by 2 plus VZ1 plus heat, or D, let's say Q, is equal to all these terms with suffix 2 plus W. Now this was your expression from steady flow energy equation. Now if you find out this work, right, that will be your actual work. If you find out this work, which is available energy, that's the maximum work. So actual work upon this maximum work will give you second law efficiency. Please note, actual work upon ideal work. This is ideal because we run the Carnot engine. Okay, and we have added that work also. So in this process, available energy gives you maximum work, which is ideal work, which cannot be really, I mean, you can't realize that. This is what you can realize. So this work is W actual upon W maximum. W actual upon W maximum. Now this was, I considered an open system. Consider a closed system, a non-flow process. Suppose we have a piston cylinder arrangement and this is your P naught. P naught is surrounding, this is P and T, okay? And if you find out, let's say we find out, there is of course heat flow and you get work, etc. Suppose you want to find out work and you apply just first law of thermodynamics. You will write Q is equal to delta U plus W, okay? And you put appropriate sign, etc. and find out this W, okay? So how much is the work output? So this will be your actual work. This will be your actual work. So this is, you are using first law of thermodynamics. Essentially, you are balancing the energies. Energy, whatever heat supplied or heat rejected, that's equal to change in internal energy plus work, output, input, whatever. Okay. So this W is your actual work. But suppose you imagine now, like we find out available energy. That means this heat will make it run through Carnot engine. We'll get that work also. Add these two works, etc. And you had got an expression. Please remember that. So expression for available energy or W max, I can say, is U1 minus U2 T naught S1 minus S2 plus P naught V1 minus V2. Okay. You can say V2 if you are taking dead state. You can say 2 is replaced by naught. Okay. Now, if you find out W max from this W max, I mean obviously it is going to be much higher than this W. So actual work, this is your actual work upon W max is your second law efficiency. Okay. Actual work upon maximum work. This is all theoretical work, please note, because we are running Carnot engine there. It's just Carnot engine doesn't exist. So actual work upon maximum work is second law efficiency. Now so this is what is second law efficiency. It's very simple. I'll also make some videos where I'll solve some numericals that would make the things very clear. And I'll also discuss about the applications of second law efficiency. But that I will do eventually in the next lecture.